Now in this case we want to find the domain and range. Domain would be the value for the x. So for this problem here, we can see from this is -3, looks like it, this point here. From point -3 all the way to the right, that would be all the values that we can assume for x-axis. So we can find a point in this region. So how do you present that? The domain would be value of x such that x is greater or equal to -3. Now in interval notation, you would write that as a brackets, -3, comma, plus infinity. So that would be the domain from -3 all the way to infinity. So it looks like so far part D give me a right domain. Can somebody tell me what would be the range? The range would be the value of y. What is it that we can, is there a restriction for y, in other words? Anyone? For the value of y? Is there anything that we cannot have? So how for the domain, I couldn't let x be equal to -5 because my graph doesn't cover -5. But how about for the y? Can somebody tell me if there's a restriction for y? So if I draw the graph here like this, see my graph gonna pass this through point like this, and it's just gonna, so like a parabola. This parabola is gonna gradually get wider and wider from each side there, and pretty much cover the whole y-axis. Does that make sense? The whole y-axis is going to be covered. So there's no restriction here for y because this graph going to get wider and wider and cover all the points on the y-axis. So that's why the range would be from -infinity all the way to +infinity. Any question on that? How to find the range and domain, everyone? Okay. I'm sorry, I didn't see who it was.
Diamond.
Can you talk a little bit louder on your microphone, please?
I said I
Who
don't
was
really
it?
understand. It's Diamond.
Diamond, okay. All right, so what part you don't understand, range or domain? Okay, let me explain that. First of all, this is not one. This means such that. This line here means such that.
Oh.
So basically, this, yeah. So this is so you don't have to present it this way, but you can just say all the domain. You can write it as domain is equal to all the number that is greater or equal to -3. That's what the domain is. Now let's see if you understand that first of all. If this is -3, okay, so if I let x be equal to, let's pick a point here. Let's say 3, if this is 3 here. If x is equal to 3, can I get the corresponding number for y that hit the graph? Let's start with that. If x is equal to 3, if I go up, this is a point, right? So we do have a point within this region here that we are saying is the domain is. We should find a corresponding number for y. So if x is equal to 3, I would find a corresponding number for y, which would be this point here. Does that make sense so far? If I say if x is equal to 4 within the region of the domain, I can find the corresponding number for y, which is right here, and so on. Okay?
Oh, okay. But it's because it hits a point for all the way
exactly.
down.
So if I pick a point -4, which is not in the domain range, if x is equal to -4, can I find a corresponding number for y?
No.
No, because my graph is not there. My graph moved all the way there. Does that make sense?
Okay.
So,
Yeah.
in other words, if my graph was moved a little bit to the left, then I would cover -4 as part of the domain 2.
Okay.
Okay. Now, for the range, however, if I pick any number, let's pick any number for y. You pick any number for y. Let's
5.
say y is equal to this point here. Okay, 4. Can I get the corresponding number for x? Yeah, right here.
Yeah. Okay.
Right. So even if I get 1,000, if I get 1,000, I should at some point I should get a corresponding number for x way out here. So even -1,000, right? If I go down -1,000, I should get a 1 million. I don't care what it is. I should, if I go far enough, because this graph is going to get wider and wider, at some point we're going to get the corresponding number for x here. So it does cover everything. So that's why the range here would be all real numbers. Does that make sense?
Okay.
Okay, good. All real numbers. Okay, so very quickly, so let me just make up a couple of more examples here. So if I have a graph look like, let's just make up a graph. Let's have this graph here. Okay, and then I'm going to call this -2. Okay. Diamond, why don't you tell me what would be the range and domain? Well, let's start with domain. What would be a domain?
Domain.
And what would be a range?
Is
Okay, let's start with the range. Range is probably easier to see here. The range would be value of y here, right?
yes.
So what would be any restricted? The value of y. So what would be the value of y here? Would be all the numbers that are what?
What I'm talking about. Maybe
No. I'm talking about the y-axis, the range. You remember this one here, this problem here? The range was the value of y, right? So here also the range would be the value of y. So in this case, we can assume any number in this for y-axis that is larger than -2, right? I cannot go below -2, right? Would it be safe to say the range would be all the numbers that are greater or equal to -2? Does that make sense? For the range, right? So if I take this graph here and bring it down here like that, now my range would be y greater or equal to -3. Does that make sense?
yes.
If I take this graph up here and put it right here, then my range would be greater or equal to whatever that number here is. Let's say 2. Positive 2, yeah, greater or equal to positive 2. Does that make sense? So if I draw a couple of multiple graphs here like that, so the range for this one would be all the y that are greater or equal to -2. So here would be the range would be all the numbers that are greater or equal to -3, and this would be the range would be very good, positive 2. Do you understand that now?
Yeah, I do.
Okay, but however, domain would be all real numbers, because this is gonna go to the right and left, gradually get increased, and then cover everything on the x-axis.
Yes. So would it be
All
-2? Would it
real.
so it would be x greater than or equal to infinity? I mean.
Yeah. So you can write it as negative infinity, comma positive infinity. That's another way you can write it.
Negative infinity plus
Anything, because if I pick a number here, let's say 3, I would find a corresponding number on all these graphs, because this graph is going to get gradually larger and larger, wider and wider. You're going to hit that graph eventually somewhere. No, would be any number on the x-axis would cover. So there's no restriction. No restriction there. So any number on the x-axis would be good for the domain. Does that make sense?
No,
if you just pick one of them, let's just pick this number here, this one right there. Okay? So in this case, the domain would be all real numbers, would be all the number from negative infinity, comma, positive infinity.
Okay.
If I pick any number on the x-axis, I would find the corresponding number for y-axis there. I pick a number here, negative 1,000 here, doesn't care what it is. At some point, because this graph gradually gets wider and wider, I would get the corresponding number for y here.
So
Does that make sense?
Can you go back to the other problem, the one before? The one where the answer...
Do you see that?
Yeah, I'm talking about the page before this one.
Yes. Can you talk a little bit louder to your speaker, or have your speaker a little closer
can
to?
you change to the next page?
Sure. Can you bring up the volume on your microphone? Oh, here you go. Sure. That one you're talking about, huh?
Yeah, so here, is it because...
This one, right?
Yeah, is it because where the graph is...
Are you referring to this
yeah,
problem?
This one. I don't know if you can see the arrow, but yeah, that one. So, because the point starts, like this is where I got confused for the domain.
Okay.
How is this one not the infinity 2 for the domain? You know what I mean? Because if it hits a point, is it because,
Okay. Right, sure. Because the graph starts from this point here, right? It doesn't move to the right. So if I write a couple examples here, it'll probably be a little bit more clear for you. I'm going to draw. Let me show you this on this page, fresh page here. If I have a graph like this, okay, this one here. Okay, the domain, let's say just 2. The domain for this would be all the number that's greater or equal to 2. However, the domain for this one would be all the number that's greater or equal to negative 3. Does that make sense? That's why. Because if I take this graph here and move it, if I take this graph here and move it to the right or left, then it would make the domain different.
So,
but the range would be all real number here. Oh, you can draw. You want me to? I'll give you the pen. Go ahead. Go ahead and draw.
So if it goes...
You should be able to draw now. Go ahead. Click on the pen and draw.
I draw really bad. So
Okay. Yeah, if it's the other way around, then in this case, for this one, I'm going to use a different color for that. So if it's like a vertical parabola like that, so the range would be all the numbers that are greater or equal to 0.
Okay. So
if I move it down here, negative 3, let's say, the range, because ranges correspond to the y, would be all numbers greater or equal to negative 3. But the domain would be all real numbers. So.
Oh, that was my question. It's all depending on how the graph is pointing
right.
and where it's at, pretty much. Okay.
Exactly right. So for like this one here, the range would be all the numbers that are greater or equal to 3. However, the domain is all real numbers. For this one, the domain is x is greater or equal to 2, but the range would be all real numbers.
Yes, okay, I understand now.
I think you got it now, all real numbers. Very good.
Okay, thank you.
And so on. Good. Yeah.